Hey guys, in this video we're looking at the multiplication property of equality. And so like in the last one we figured out we can add and subtract on both sides of an equation. So this one we're doing multiplying and dividing with both sides of an equation. And just as a little refresher, I'm going to do a little fraction review for multiplication, division with fractions to start things off. So there's kind of two things you do when you multiply fractions, which is you multiply and then you simplify. And the order in which you do those is actually, you can kind of go either way on it. And so I could multiply straight across and get that, and then break it down and simplify. And actually I picked some numbers that made that really easy, but sometimes that's not really easy. The other way to look at it is if I think of this as 10 over 9, and then I'm just going to take this negative and throw it out front because I know my answer is going to be negative. And then the 7, do a little times 2 times 10. If I kind of think of it that way, then I can say I can cancel those 10s, is the deal. And then I would have negative 7 up top, and then 9 times 2 be 18 down below. And I can see everything here, so I know I don't have to reduce this anymore because the 7 isn't going with the 9 or the 2. When you do this kind of a little faster than what I just did, a lot of times the way that you write this is you just go, if you can see that the 10 is going to go into both, you just go 10 goes into 10 once, 10 goes into 20 twice, and that's a much cleaner way to write it than all this stuff. But this is what you're doing, is you're knocking out those 10s. And then here you just say 1 times negative 7, whoops, I dropped my sign, negative 7, and then 9 times 2, there's our 18. So this is a lot quicker way to write it, but I just wanted to show kind of what was going on with the math behind that. This one's a division, and so for division we have to do the reciprocal of the second fraction and then multiply. So, and then also it's two negatives here, so it's going to be a positive, so I'm just going to drop those two signs and then rewrite it as a multiply. So I could go 35 times 8 and 6 times 5, but I could also kind of look at it and go, 5 goes into 35, and these have a 2 in common. So if I do that, again, I think I'm going to write out, no, I'm just going to do it. So 5 goes into 5 once, and then 5 goes into 35 7 times. I just think this is cleaner. And then here we got some 2's going on, so we can go 2 goes into 6 3 times, and 2 goes into 8 4 times. And then the stuff that's left, I just multiply straight across. So 7 times 4 makes 28. 3 times 1 makes 3. So to me it's easier to do the simplify piece before I do the multiply and make the numbers all big. Okay, if we're doing this in a lecture class, I would have you guys try these two examples next. So I'll just go ahead and do them here. So I'm just kind of looking for what these would have in common. And it would go 5 goes into 25, or I could say 5 goes into 5 once, 5 goes into 25 5 times. And then 7 and 21, 7 is going to go in. So 7 goes into 7 once, and 7 goes into 21 3 times. And then I just have to say 1 times 3, 1 times 5. Which to me is easier than getting whatever that would have been, I think 105 over, so that would be 175. So if I just multiplied straight across, I would have got this. And then I could have like taken a 5 out of there, taken a 5 out of here, and then try to figure out that I could also cancel another 3 after that. Sorry, it was a 7 that we canceled. So it's to me that's a lot more work to make it big and then cancel than it is to just cancel first and then boom, there's your answer. You hardly have to multiply at all. This one, so same thing with the double negatives. I'm just going to rewrite it as a positive. And division, so I'm going to do the reciprocal of the second one. Oops, yeah, there we go. And so now we just kind of look and see what do these things have in common? Is there anything to get rid of? You can see 8 times 33, 9 times 32. I know that'd be a giant number. It'd be really hard to reduce. So way easier way is to go, okay, 8 and 32, those have 8 in common. So I'll say 8 goes into 8 once, 8 goes into 32 4 times. And then 9 and 33, I can get a 3 out of there because 33 is 3 times 11. So 3 goes into 3. 3 goes into 9 3 times, and 3 goes into 33 11 times. And so that would have been a super hard fraction to reduce, and now I just get to go 1 times 11 is 11, 3 times 4 is 12. Okay, so with these next ones, we're kind of starting more with the multiplication property of equality. The idea is we can, if it's convenient to multiply something or divide something, we can do that as long as we do the same thing on both sides. And so looking at this first example, our goal has been to just get x by itself, right? We're trying to get 1x. And you can just kind of look at it again and see it's going to be a -6 is what would make that come out to -24. But as always, we got to get kind of some way to get there for when the problems get harder. And so that's where this comes in. If I'm multiplying and I want to undo a multiply, then what I can do is I can just divide. Because 4 over 4 is going to make a 1. Remember, that's what we're trying to get to is 1x. And just what I do on this side, I have to do on that side. And so then we can see that -6 pops out right there. So this next one, let me rewrite that to make that a little clearer. So this time the 4 is dividing, and so to undo division, we multiply. So we'll go times 4 times 4, but sometimes this floating 4 kind of freaks people out in terms of the fraction. So if it helps, you can write that as 4 over 1, and then maybe it's a little easier to see, okay, the 4's are canceling, x over 1, that would just be x, and then 5 times 4 would make 20. Down here, we got division, but now we're picking up some more fractions and some signs. So we got negative and 5 equals negative. So we gotta get rid of the negative and a 5 downstairs. So it means I gotta have a 5 up top, so I'm canceling the 5s. And then I want this to be positive x, so I need to do -5, so that a negative times negative will make a positive. And then what I do this side, I have to do over here. And so now the negatives make a positive, 5s cancel, so my x is all by itself. And then negative and negative is going to make positive. And I could go, let me go ahead and show that. 55, and then 10 times 1, so that would make over 10. And this is where I was saying, now I do have to catch the reducing, right? So I could think of it as 5 times 11 over 5 times 2, and cancel the 5s right there. The other thing I could do is back here, I could say, like we did on those last ones, 5 goes into 5 once, 5 goes into 10 twice, and there's that same, and the double negative's a positive, 11 over 2 that I got this way. So if you can catch it here, again, I think it's a little easier, but if not, you gotta catch it at the end there. Number 8, so this one's got a fraction, a full-on fraction in front, and those are actually pretty easy to deal with. All we gotta do, we're essentially going to multiply by a 9 and divide by a 2, which is just multiplying by the reciprocal of this. So again, we want to use the same sign. If it's a positive, we use positive. Negative, we use negative, so it comes out a positive. And we'll do 9 halves there, and then negative 9 halves there. So negative, negative makes positive. 2's are gone, and the 9's are gone, so there's our x all by itself. And then here, I could go to, this would be 90 over 54, and then I'd have to reduce that, which just, I mean, it's a little bit of work. So I think it's easier if you catch it right down here. 2 goes into 10. Well, how about 2 goes into 2 once, 2 goes into 10 5 times. And then 9 and 27, so 9 goes into 9 once, 9 goes into 27 3 times. And then you don't have to do all that reduction at the end. So we get 5 thirds, 5 times 1, 3 times 1. Okay, and these next two, if we're in class, I'd have you guys try. So 5 6x equals 25. And go like this. 6 over 5. This. 6 over 5. 25, again, if it's kind of floating and it's bothering you, think of it as an over 1. And then cancel that, x all alone. And we could go, 150 over 5, but again, probably easier to just catch it right there. 5 into 5 once, 5 into 25 5 times, and then there's our 30. And then this one, so we got a 3 downstairs. That means we need to multiply by 3s because we're dividing by 3 right now. And we do the same thing on this side. Threes cancel. Here I would get negative 3, 6. I'll go ahead and go 3 into 3 once, 3 into 6 twice, and then I got x equals negative 1/2. Okay, so then it kind of goes into the problems that look like yesterday's, or the ones in 1.2, but this time we're going to have x's with numbers in front, so they're not all going to just turn into plain x. So using a lot of those same skills from the last couple sections. So with this one, we need to get x by itself, and so we want to do our addition, subtraction first, our multiplication, division second. So kind of the same order that we've seen this come up in the chapters. First we learned to simplify, which we're going to do here. We'll simplify first, and then we did add and subtract, which is our next step, and then now we got multiply, divide, and that's kind of our third step. So nothing to simplify, so I'll go to the add and subtract. So I'm going to go minus 13 on both sides to get that 13 out of there, because I'm trying to get at the x. And that gets us 5x. Those are gone. Minus 12 minus 13, so we're getting more negative, and that's going to be negative 25. And then we've got a 5 multiplying, so I have to divide to undo that. And 5's cancel, and I got x and negative 5. So this one, so we'll go back to the simplify 1.1 section. I'm going to put all this stuff together as much as I can, and then kind of see where that gets me. So right here I got x plus 5x, that'd be 6x, and then minus 9 would make minus 3x, and then that plus 6 not like terms, so I gotta leave that out. And then, so we're kind of so I've simplified, so now I want to do my add subtract to get things away from x. So I'm going to say minus 6, minus 6, and those are gone. And now I have negative 3 multiplying x, and so that's where this section comes in, is that divided out. And x equals 6. Okay, so now we have entered the land of the terrible fractions. These are a little terrible. If you try to do them where you just sort of add stuff over, add this 2/5 over and combine that and then divide the 3/10 over, it will be a really hard problem. Like, it's not impossible, but you're doing a lot of steps there. There's this other way to do it that is a little harder to figure out how to do at this beginning, but once you learn it, it makes these like so much easier. So I'm going to show them that way. So this is the one where we just kill off all the fractions in the very first step. So what I'm going to do is we're going to use the LCD for all the fractions, so 5, 10, and 2. My LCD would be 10, because 5, 10, and 2 all go into 10. And I'm going to multiply both sides by the LCD. This is like 10 over 1. And the idea is we're going to be able to cancel everything because we're using that common denominator. I'm going to show a step in between here, and the goal is to get where you're comfortable skipping this step. But usually to see how the canceling works, it helps to write this out a few times. So I'll show it that way. So I'm just going to multiply this 10 in. So that's going to be, negative right there. 5. 10 times 3, so that's going to be 30 over 10x. And then 10 times 1 will be 10 over 2. And so you can see, since I use the LCD, now all of these fractions are going to simplify. So 20 over 5, that's going to give me a 4 right there. 30 over 10, that's going to make a 3x. And then 10 over 2, that's going to make it come out to 5. So then once I've done that, if you look at the original problem and you look at this is so much easier to work with than what we had going. And so that's where this step is a little tough, but it gets you to somewhere that's like much, much easier. I'm going to take a second and talk about how, once you kind of get good at these, how you can look at it and skip this whole line. So once I got the 10 up here, the way I think of it is 5 goes into 10 2 times, and then 2 times 2 makes that 4. Here, the 10s would just cancel, and boom, I'm right at that 3x. Here, 2 goes into 10 5 times. So you want to get where you can just do that and not write out all this stuff. But if you're having a hard time seeing the canceling, this will help you see the canceling. So once we do that, now we're back to not too bad. I got this, I want to do my add subtract first, so this time I got a -4 because I'm trying to get the x, so I want to go at +4 to undo that. That drops out, equals 9, and then lastly we do our divide. So I'll divide out that 3 on both sides, and that equals 3. This next one is basically the same thing. I just wanted to show this canceling step a couple of times because that's it's a really useful technique, and it's a little hard to learn, but I do encourage you to learn it, and we'll use it a bunch. Okay, so I got this 8, 2, 4, and 4, so I'm going to multiply everything by 8. Gotta be careful to use the same thing on both sides. I'll see people kind of go, okay, I need to get rid of an 8 over here and then a 4 over here, but now the sides aren't equal anymore, so careful, use the same number. I'm going to write it 8 over 1 to make that look a little easier. So let's see, I'm going to go ahead and show this step one more time, and then I'll kind of talk through like I did here. So this would be 56 over 8x minus 8 over 2 equals, on this side 8 times 1, so 8 over 4x, and then that'd be 24 over 4. And then I can just reduce each of these fractions. Here I got 7x. 8 divided by 2 is going to make 4. 8 over 4 makes 2x. And then 24 over 4 would be 6. And so again, this looks so much easier than that. And let me talk about, to get from here straight to here. So I would just say 8 over 8, so those cancel, and there's my 7x. 8 over 2, there's 4. 8 over 4, there's 2. And then here you kind of go 4, that would leave a 2, 2 times 3, and there's our 6. So try to get where you can get from here to here, just like I did there. Once we got that, okay, so now we're going to get, in this case we got our first x's on both sides. Okay, that's cool. So we want to get x's to one side and numbers to the other. So I'm going to get my x's combined over on this side. It doesn't really matter which way, but we'll do that. And then this is going to go 5x minus 4 equals 6. And then we'll pop this over. And we got 5x equals 10. And then divide out the 5. And x equals 2. And so I'm doing these all just kind of one step at a time. Again, if you become more comfortable, you can just go plus 4 right here, and then you're at 5x equals 10. I'm showing multiple steps just because people are just learning this for the first time maybe. And then these last couple are the ones I would have you guys do in class. So let me just run through these. So this is a fairly friendly one. We'll just get our x's to one side, numbers to the other. Add the 7x over. And that'll give us 12x. I'll bring my 6 down, equals, those are gone, and negative 12 on this side. So now I want to get everything away from x, so I'm going to say minus 6, minus 6. And then I can divide the 12. And those cancel. And then this is that almost right answer, except we got, it can simplify a little bit. So if I think of this as negative 6 times 3, and I think of this one as just 6 times 2, and cancel those 6's out, and then I get x equals, negative 3/2. And last one here, we got some fractions to clear. So let's see if we can, this one I'm going to show where I just go straight to the line, I think, just to kind of do one that way. So 3, 12, and 4, we'd use a 12, that's our common denominator. And so here we got 3 into 12, so that's going to be negative 4. And then plus, here the 12s would just cancel, 5x, 4 into 12 equals 3. So again, once you kind of get good at this, it's pretty easy to clear those fractions, and that's a much easier problem. And then I want to get everything I can away from that x, so I'm going to go plus 4 to both sides. going to be 5x equals 7, and then just divide the 5 over, and then that's it. X is 7/5. Cool. So that concludes the multiplication property of equality.